when Google's quantum-enhanced AI systems were handed new telescope images of the enigmatic object labeled 3I/AT. No one could have predicted the results. Built to detect patterns far beyond human capability, the system began flagging strange irregularities in the data. What was expected to be the routine classification of another icy wanderer instead set off quiet alarm among astronomers. The machine's readout suggested this wasn't an ordinary comet, and if the AI's interpretation proves correct, humanity may need to pay very close attention to this uninvited traveler. The breakthrough came on July 1st, a morning that began like any other for astronomers stationed in Chile. Yet what their instruments revealed would ripple through the scientific world with stunning force. Nestled within the observations from the automated ATS telescope was an anomaly that simply should not exist. Against the star-sown black of space appeared a faint but luminous dot, moving with breathtaking speed. This wasn't a run-of-the-mill asteroid or cometary body. This was something foreign, cutting through the solar system on a direct path toward our neighborhood. Scientists quickly realized the movement was staggering, over 130,000 mph, fast enough to travel the New York-Los Angeles route in only a single minute and change. For comparison, commercial jets take 6 hours. This object could manage it in just 67 seconds. Within just a day of the initial detection, NASA's experts were locked in around-the-clock computations. Their findings confirmed the almost unbelievable. The object had entered from deep interstellar space, traveling from well beyond the frontiers of our sun's influence. At the time of observation, it was already nestled within Jupiter's orbit, some 327 million miles from Earth. But by the time this account reaches discussion, the body has swept much closer, slipping past vast stretches of the inner system and nearing Mars. Officially, scientists named it 3 Atlas, the 3 signifying its place as only the third interstellar interloper recorded, after the cigar-shaped Oumuamua in 2017 and Comet 2I/Borisov in 2019. But unlike either of its predecessors, this visitor stirred questions of a far more unsettling nature, questions that had even seasoned astrophysicists whispering about the possibility of artificial origin. Adding to the unease was the fact that our telescopes had missed it until the 11th hour, concealed by a dense, radiant patch of stars within the Milky Way. Its approach had been hidden from view until far too late to mount a proper probe or interception. It almost appeared as though its concealment were deliberate, as if it had slipped past unseen until evasion was no longer possible. What followed next stretched belief. When researchers derived its estimated dimensions, the results seemed too astonishing to accept. Calculations were rechecked countless times. While Oumuamua measured roughly the size of a football field, between 330 and 380 feet long, this new body was colossal by comparison. Estimates placed its width somewhere between 6 and 9 miles, making it tantamount to watching Manhattan Island tear through interstellar space. From there, the calculation only became more disturbing. At a velocity of 36 miles per second, 3 Atlas was moving too fast even for the sun's mighty gravity to ensnare, ensuring it would slice through our neighborhood and keep going. That is more than twice the speed of most solar system roamers. By contrast, Voyager 1, our fastest spacecraft and pioneer of interstellar travel, would appear nearly frozen in place beside this speeding Leviathan. Yet neither size nor speed accounted for the most mind-bending revelation: the intruder's flight path carved an unconventional, almost impossible trajectory, defying predictions and demanding repeated recalculations. A visitor of monumental size, unearthly velocity, and impossible motion, 3 Atlas was a discovery astronomers were not sure how to interpret, leaving them with an unshakable sense that something extraordinary had just entered human history. Most interstellar objects behave predictably, their movements determined by gravity and momentum. Typically, they streak through our solar system in almost straight lines, only tugged slightly by the sun's pull before vanishing back into deep space. 3I/Atlas, however, wasn't conforming to those rules. Instead of simply flying past, its projected orbit would take it on a striking tour of the inner solar system. On October 2nd, it was expected to skim within 17.5 million miles of Mars, a distance that, in astronomical terms, feels like brushing shoulders. By December 19th, It would make its closest pass to Earth at about 167 million miles. Afterward, its path would carry it to just 60 million miles from Venus and eventually return it near Jupiter in 2026, approaching the gas giant at only 33 million miles. What unnerved scientists most was the statistical improbability of such a path occurring. By random chance, calculations suggested odds lower than 0.005%. In other words, nearly every other wandering object from beyond the stars would never come close to more than a single planet, let alone several. The fact that 3I/Atlas was positioned to observe multiple worlds so directly made even hardened skeptics question whether they were watching something natural at all. The path looked engineered, not coincidental. Harvard astronomer Avi Loeb and his research team devoted weeks to studying every element of the object's motion. Their conclusion was chilling. This was not a random trajectory, but what mission planners would call a textbook grand tour. If humanity wanted to send a probe to study as many planets as possible in one journey, this is almost exactly the path our engineers would design. The precision was unnerving. It would pass near Mars at a distance ideal for high-resolution data gathering, glide by Earth closely enough to undertake thorough scans while staying well out of danger, then edge even nearer to Venus on its next pass. The afterward encounter with Jupiter could provide a gravitational assist, a natural slingshot capable of altering its course for future maneuvers. Watching 3I/Atlas seemed less like observing a cosmic accident and more like witnessing choreography written with intent. The timing made the strangeness worse. When its closest approach to Earth arrives on December 19th, it will be in an almost ideal position to view us, bathed in full sunlight, while our view of it will be obstructed by the sun itself. Loeb questioned whether that alignment was accidental. Perhaps, he suggested, it was purposefully arranged to maximize its ability to watch us while minimizing our ability to study it. And if this was indeed a probe of alien design, an even more disturbing curiosity emerged. Earth did not appear to be its main focus. Its trajectory favors Mars, approaching nearly 10 times closer to the red planet than it would to us. This raised the unsettling idea that its operators might prefer to avoid direct contact with humanity, while still keeping us under distant observation. Another possibility unsettled the academic community further. Maybe it had no intention of departing. By harnessing complex gravitational assists around Jupiter and the Sun, combined with potential propulsion, it could slow enough to settle into a sustainable orbit within our system, allowing long-term surveillance. Humans already employ such techniques, known as orbit adjustment strategies, in robotic missions. And any civilization capable of traveling between the stars would almost certainly command this skill as well. Yet the most unnerving revelation of all came from its timeline. Based on its speed and course, scientists traced its crossing into our solar system's boundary back roughly 8,000 years. This period eerily coincided with humanity's transformative era, when the first great civilizations, organized cities, and early writing systems emerged. The thought that these milestones might have signaled our presence to a distant intelligence carried both wonder and dread. As discussions about 3I/Atlas deepened, some researchers invoked one of the most ominous ideas in astrophysics, the dark forest hypothesis. If the cosmos is like a dark forest filled with hunters, then any visitor program to move so purposefully through our system might represent more than just exploration. It could signify contact in its most unsettling form. The idea traces back to physicist Enrico Fermi's famous question from 1950: if the galaxy should be brimming with advanced civilizations, as probability suggests, then why haven't we encountered them? The dark forest hypothesis offers a chilling answer, one that makes the sudden appearance of any interstellar visitor deeply unsettling. According to this theory, intelligent life does exist scattered across the universe, but survival requires silence. Civilizations remain hidden because announcing their presence can bring annihilation. Much like creatures in a dark forest that invite predators by making noise, advanced species may have learned to conceal themselves. To draw attention is to risk discovery by a stronger, more hostile power that either destroys perceived threats or exploits weaker ones for resources. If 3I/Atlas were truly an engineered craft from another civilization, its very presence would mean its creators had developed technologies far surpassing anything humanity has achieved. Crossing between star systems would not only demand propulsion systems beyond our comprehension, but possibly weaponry or capabilities that dwarf even our science fiction imaginings, even if the object were nothing more than an autonomous probe. The fact that it may have catalogued Earth at all brings forth the most unsettling question: why were we discovered? And for what purpose? The grim possibilities extend in several directions. In most optimistic case, humanity might be judged as inconsequential, far too primitive to matter, and thus ignored at its darkest. However, we could be assessed as a potential long-term risk, one that must be eliminated before our species matures into a rival competing for resources or territory. Another unsettling possibility is that our discovery didn't start with 3I/Atlas at all. Perhaps it was preceded by earlier scouts. In 2017, the object known as Oumuamua passed through our solar system and displayed a host of inexplicable behaviors: an abnormal trajectory, acceleration seemingly without cause, and a total lack of the physical traits expected from a natural object. Could Oumuamua have been a preliminary probe, with 3I/Atlas launched later as the main vessel? This interpretation is supported by their size difference and timing. Oumuamua stretched only as large as a football field, consistent with a reconnaissance craft, while 3I/Atlas spanned miles across, more like a command ship or mother vessel. The 8-year gap between their visits could reflect the time required for data transmission across interstellar distances, followed by preparation and deployment of a larger mission. If true, then humanity is no longer witnessing random cosmic passers-by. We may be facing the next phase of a carefully orchestrated investigation. To grasp the weight of this possibility, one must revisit the first messenger that started the chain of mysteries. In 2017, astronomers using the Pan-STARRS telescope in Hawaii detected a strange intruder from beyond our solar system, later named Oumuamua, meaning messenger from afar arriving first in Hawaiian. Initially, it was believed to be a long-sought chance to study an interstellar object up close and gain answers about the wider galaxy. Instead, it became one of the most baffling astronomical events ever recorded. Oumuamua was already speeding out of the solar system by the time its true nature was recognized, leaving scientists with only a fleeting window of observation. The data defied expectations. Unlike ordinary comets, it exhibited no luminous tail of gas and dust despite a close pass with the sun. Its shape was profoundly unorthodox, either a cigar-like elongation or a flat, pancake-like disk. Unlike any known natural body, most unnerving of all, it accelerated after slingshotting past the sun, as if propelled, yet no outgassing, the typical cause of comet acceleration, could be detected. Its silence and strangeness made Oumuamua the subject of intense debate and speculation, setting the stage for the alarms surrounding 3I/Atlas. When typical comets draw close to the sun, the rising heat causes their frozen gases and ices to vaporize, forming the glowing tails that make them so striking to observe. Oumuamua, however, passed just 23 million miles from the sun's surface, close enough to incinerate nearly anything, yet showed no signs of evaporation. It behaved as though composed of a material capable of withstanding extraordinary temperatures without alteration. Stranger still was the object's sudden acceleration. Roughly 40 days after its solar flyby and before its discovery, it increased speed dramatically. At its peak, it accelerated to 54 miles per second, 5 times faster than NASA's Voyager 1, 11 times faster than SpaceX's Starship rocket, and 250 times the speed of sound. Generally, such changes only occur in comets when jets of gas burst outward from evaporating ice. But Oumuamua displayed none of those traits. Something had propelled it forward, but the source of that force remained a mystery. Its proportions and shape added to the intrigue. Initial assessments placed it at roughly 377 feet long and 364 feet wide, dimensions comparable to a football field. This size was intriguing, large enough to house advanced instruments, yet small enough to accelerate efficiently across interstellar distances. In fact, if one were to design a reconnaissance craft for visiting alien star systems, it could plausibly look very much like what we observed in 2017. This first interstellar visitor, with features that resisted natural explanation, cast a long shadow, So when 3I/Atlas appeared 8 years later with its own baffling traits, speculation that the two might be linked as part of a larger exploratory mission became nearly impossible to ignore. The extraordinary sparked heated debate, while some researchers, including Avi Loeb, insisted that both Oumuamua and 3I/Atlas offered evidence of non-human technology. Most of the astronomy community countered with theories that tried to situate these anomalies within natural phenomena. The question revealed how difficult it was to parse true artificiality from unusual cosmic processes. For Oumuamua, a number of competing hypotheses emerged. Alan Jackson and Steve Desch of Arizona State University suggested it may have been a nitrogen ice fragment broken off a Pluto-like planet in another star system. They argued that as this chunk of nitrogen ice passed close to the Sun, it could have vented just enough material to create acceleration without producing the characteristic visible tail of a comet. Another line of reasoning came from Darrell Seligman of Cornell University and Jennifer Bergner of UC Berkeley, who proposed that Oumuamua began as an ordinary water ice comet wandering through interstellar space for millions of years. Over that time frame, cosmic rays from supernovae might have converted a significant fraction of its frozen water into molecular hydrogen trapped inside the object. Upon warming in proximity to our Sun, this hydrogen could have leaked out in extremely faint jets, providing thrust but producing little to no dust or visible glow. Skeptics applied similar reasoning to 3I/Atlas. Evidence emerged suggesting it behaved more like an unusually massive comet than an alien craft. Recent images revealed a weak but distinct glow, or coma, a hallmark of comets as sunlight begins to warm them. Though subtle at first, astronomers expected this halo to intensify as the object drew closer to the Sun. Its brightness also implied a surface rich in reflective ice, consistent with naturally icy comets. Specialized spectral imaging even captured hints of a faint dust tail extending from 3I/Atlas, albeit far less obvious than typical comet structures. If accurate, this meant that the object was indeed showing the subtle evaporation patterns associated with ordinary cometary activity, just scaled up due to its size. Its physical dimensions, while vast at 6 to 9 miles across, were not beyond precedent. In fact, considerably larger comets had already been recorded. In 1997, Comet Hale-Bopp, visible even to the naked eye, had a nucleus measuring roughly 46 miles across. The enormous Bernardinelli-Bernstein comet, discovered in 2021, stretched to about 85 miles, dwarfing both Hale-Bopp and 3I/Atlas. By this measure, the latter's size could not, in itself, be regarded as proof of artificial construction. Samantha Lawler, an astronomer from the University of Regina specializing in planetary dynamics, argued that the data supported the object simply being a natural comet ejected from another system. According to her, such expulsions are common throughout the galaxy, with planets or migrating stars regularly flinging icy bodies into interstellar space. The fact that we've only identified a handful of these so far, she suggested, reflects the limitations of current detection technologies rather than true rarity. Still, even among skeptics, one point carried lingering doubt: the object's route. Despite naturalistic explanations, no consensus emerged as to why 3I/Atlas seemed to follow such an improbably precise grand tour of our inner solar system. Its trajectory remained one of the most confounding aspects, an unresolved riddle at the heart of the debate. The odds of such a trajectory occurring naturally continued to remain strikingly low, fixed around that unsettling 0.005% probability. Even as researchers worked on alternative natural explanations, the accuracy of the object's flight path gnawed at even the most level-headed astronomers, leaving them to wonder, was 3I/Atlas the product of chance, or something far more intentional? Racing the clock to uncover answers as the interstellar traveler pressed deeper into the solar system at extraordinary speed, astronomers worldwide realized they were racing against time. Unlike Oumuamua, which was spotted only after it had already begun exiting, the new arrival offered a rare opportunity to observe an interstellar body during its inbound journey, at its brightest phase. But this window would be painfully short. Immediately following its discovery, telescopes across the globe were rapidly redirected to track the fast-moving visitor. Each cloudless night became a critical chance to secure spectrographic readings, measure its rotational pattern, and monitor any visual changes in its surface activity as it drew closer to the Sun. The information gathered in these fleeting months might have to sustain decades of analysis, given that a comparable opportunity might not return in a generation. What sharpened the urgency was its projected orbit. When 3I/Atlas reached closest approach to Earth in December, it would be situated on the far side of the Sun, making it virtually unobservable just when it would otherwise be most available for study. The timing of this solar conjunction seemed suspiciously deliberate, almost as if designed to obscure the object from our view, further fueling speculation about its artificial origins. As a result, astronomers had only the months leading up to conjunction to capture their most vital datasets. This struggle emphasized humanity's vulnerability in dealing with unexpected guests from beyond the stars. Planned probes to comets and asteroids typically take years to prepare, but interstellar visitors appear without warning. With 3I/Atlas, scientists had no choice but to make do with current instruments, ground-based, telescopes and orbital observatories, and hope for favorable conditions. The challenge of direct exploration, some experts floated bold ideas, dispatching robotic probes to chase down the object. Yet the sheer velocity of 3I/Atlas, combined with its unusual route, made such a venture nearly impossible with present-day propulsion. Any interceptor would need to reach record-breaking velocities and align its trajectory with extraordinary precision, a feat that current mission planning tools and spacecraft simply could not deliver. One promising concept in development, ESA's Comet Interceptor mission, scheduled for 2029, offered a strategy for future encounters. Rather than trying to catch up with fast-moving visitors after they were detected, the interceptor would wait at a gravitational balance point in space, poised to deploy smaller probes the moment an interstellar body appeared. Unfortunately, the timetable meant it would be years too late to study 3I/Atlas. That sense of lost opportunity weighed heavily. Had discovery come even a year earlier, space agencies might have had the chance to launch a dedicated mission. Probes could have intercepted the object directly, perhaps even attempting a controlled landing to scoop samples. Such a mission might have conclusively revealed whether this was a natural entity or technology from a distant civilization. Instead, scientists found themselves restricted to remote analysis, hundreds of millions of miles removed, a puzzle left unresolved despite the frustration. The campaign surged forward. Every new image, spectral reading, and light curve was added to the rapidly expanding archive of data. Yet the essential questions persisted. Untouched by certainty, was this immense wanderer simply another icy body expelled from some alien star system, or was it something designed? A constructed probe surveying our planets with intent? For astronomers and the public alike, the scramble to observe 3I/Atlas had become more than science. It was a race to decipher whether humanity was confronting its first tangible evidence of extraterrestrial technology, or merely witnessing the strange behaviors of an unusually massive comet.